Hello. In this assignment number 6, we created shadow or shader outlines that dynamically adapted themselves to the object's shape or geometry. I will demo what the result output looks like after the implementation and what it had looked like previously. So I will run this file, and this is what we had in our original code. We can see that the shader outlines are rendering everywhere and also around the sphere, and the background color is not changed. Then if we get the code from our working SRC file and run that, we can see what the output looks like right now. So when the light beam is coming from the camera angle, is aligned with the light beam is not coming from the camera, but it's coming from above. And when the light beam is aligned with the surface normal, the illuminated area is smallest. And when the surface receives the maximum amount of light, it's much smaller as well. When the light beam hits an angle, the illuminated area is larger, and the same amount of light is spread out more thinly. So the surface receives less light when that happens. When the light is completely parallel, though, the light's not hitting the surface, so it's in shadow, and it gets an outline, and it gets zero direct light from the light source. I will talk about the code that I am explaining. So in this first line, I'll be explaining how we set the background color to blue. So the function glClearColor is waiting for the values for the red, green, blue, and alpha, and it's taking the 4 values as floats between 0 and 1, and then we're going to be converting the RGB values to OpenGL's 0 to 1 range. So this is effectively producing the light blue or baby blue color. And then we're dividing by 255 here because we are normalizing the standard 8-bit color values, and that is what fits OpenGL's floating point range. Talking about this line, float normal equals calculate face normal model face. This line is computing the normal vector for any of the given faces in the 3D model. It's going to focus on the perpendicular vectors to the surface, which is going to help with the calculating of the lighting. So to create realistic shaders and outlines to make the lighting effects just more realistic. Without calculations like this, without using the information from the vectors from the object's faces, then it would not have anything to base the shading off of, and it would be like emulating the shading effects, but to a worse degree, and it wouldn't look as realistic. So yeah, this line is just making sure that it interacts properly with the light, and it's computing the normal for each of the faces dynamically.